Hello friends, today we are going to discuss an interesting application of matrix algebra, that is cryptography. Now, what is cryptography? Cryptography is nothing but the method with which we import files, messages, or any other such context objects to only that relevant user which has the password for the required object, and none other than the password holders can access to these files or required objects. In this, we consider the alphabetical letters of the sequence, that is from A to Z, as from 1 to 26. Now suppose if we give a message like face, then the numbers corresponding to it are 6, 1, 3, 5. Now here is where the matrix algebra and the most fundamental operation of matrix algebra, that is multiplication, comes into our aid. Now this face message is transmitted in the form of a matrix which is called command matrix. Here it is important to note that all the letters are arranged in an order, such an order that there remain only two columns, such as for the face the required command matrix is of 2 by 2. Suppose if we give a command of 8 letters, then its order will be 4 by 2. In such way, we retain that the order of the matrix is always 2. So this matrix is the command matrix as it is formed from the word face, that is the command which we have given. Now, suppose the owner of the file or the object which uses another key matrix which is called security matrix. This security matrix let be represented by B. So this is the matrix which when multiplied with this matrix will convert into a transmission matrix. So suppose let this matrix be A. So if B is the security matrix of the owner of the object or the file, then the X matrix, which is the transmission matrix, will be equal to product of AB is equal to X. Now B is the matrix which the owner of the object gives so that only the relevant people can access it. Now when these two multiply, we get a resultant matrix X. Now the data is now transferred in the form of the resultant matrix, which is the transmission matrix. That's why it is called a transmission matrix. Now, when a relevant user tries to access this file, he is given a code which is exactly the inverse of the security matrix, which is B inverse. Now again, he has to decrypt the transmission matrix by multiplying this with B inverse, which is the encrypting key to open this file. Therefore, we can write this in matrix algebra as X B inverse is equal to AB into B inverse. Now again it becomes XB inverse into AB B inverse. Now we know that the multiplication of a matrix with its inverse is always an identity matrix I. So it becomes AI and the LHS remains X into B inverse. So the A matrix becomes X into B inverse. And when we multiply these two matrices, transmission matrix and the encrypting key, we again get the same matrix A command, which is the command matrix which we have earlier given to the access file or code. So now similarly, we have been given an encrypting problem here. So we will try to solve it using the similar algorithm we have discussed above. First, in a cryptography code, a command of word of 6 letters is assigned to a source graphic code whose security matrix S is equal to 5273. The product of the command matrix and security matrix, that is transmission matrix, is 12551, 11547, 14562. What will be the command word if the encrypting key is S inverse? Now we have been directly given that the encrypting key is S inverse. So we can use the above algorithm to find out what is the command word. Now we write down the matrix is given. Security matrix S is equal to 5273. Now if you want to find out its inverse, as it is required because the encrypting key is the inverse of the S matrix itself, so its inverse will be 1 upon determinant of S into adjoint of S. Now further calculating S determinant, we get which is equal to 15 minus 14 is equal to 1, and adjoint of the matrix S, that is security matrix, becomes 3 minus 2 minus 7 5. Now here the main point comes. Now we have been given that the transmission matrix is the product of the command and the security matrix. So to obtain the matrix of the command word, we need to multiply S inverse with transmission matrix T. So using matrix algebra, here we can write this as C is equal to T, where we have considered C as the command matrix. Now using matrix algebra, this expression can be simplified as C into S inverse is equal to 2 TS inverse. But S into S inverse becomes identity matrix I. So it becomes Ci into T inverse. Therefore, C can be written as T into S inverse. Now we have been given the transmission matrix C. So it becomes easy to find out the command matrix and ultimately the command word. Now the transmission matrix is 125 51 So this is the required transmission matrix, and S inverse, as we have find out above, is 3 5 minus 2 minus 7. So by using matrix multiplication, the product of these two matrices will be 125 into 3 minus 51 into 7. So this becomes 375 minus 357. Now solving for subsequent rows and columns, we can write the other entries of the resultant matrix as minus 250 plus 255. Now the third entry, 115 into 3 is 345, minus 47 into minus 7 is 329. Then 115 into minus 2 is minus 230, and 47 into 5 is plus 235. Now in the last row, 145 into 3 is 435, minus 62 into 7 is 434, and the last entry will be minus 290 plus 310. So our resultant matrix will be 18 5 16 5 1 and 20. Now again, as we have discussed in the above discussion, that the command is correlated with the numerical order of the alphabets of English language. So if we consider A to Z as correspondingly to 1 to 26, then these letters can be written as 18, 5, 16, 5, 1, 20. So we have written these numbers in a single line and it forms a command. Now the letters corresponding to these numbers will be R, E, P, E, A, T. So what do we find? We find that our command word was repeat. So we find that our command word was repeat, which was encrypted in a matrix and was multiplied with the security matrix as transmission matrix, and ultimately we again get the command word which is transmitted to the file. So our command word will be repeat. So hence, in this way, we can solve many encryption problems using matrix algebra and most particularly matrix multiplication. I hope you enjoyed this video. Thank you.